All right, folks, we're almost there. We're to unit 7 out of 8, so only 2 more to go, and we'll be finished with the review part, and we'll just then really practice FRQs and multiple choices for the rest of the time. So we want to talk today about separable differential equations and what it means to solve one. So a differential equation is given in the form of dy over dx. So you're starting with a derivative, and it's in terms of multiple variables. So you have both y and x describing the differential equation. A lot of times you can use this to make a slope field. Okay, a slope field is a visual drawing of a differential equation. But if you want to solve it, we use the strategy separate and integrate in order to solve a differential equation. So the word separable kind of gives it away, that you're going to be separating and integrating. All right, so we need to make sure we understand what the difference between a general and a particular solution is. So a general is in the form of y equals something, a solution, plus c. A particular solution narrows that down, and you have a specific, you solve for c, okay, a known value for c, and you use the initial condition, the initial value, to solve for that. All right, so you'll be given an initial value, and you'll have to use that to solve for c. Now, a lot of times this initial value will help you determine whether you use, if your solution has a plus or minus in it, you refer to the initial condition so that the initial value, so you can say, do I use the plus or do I use the minus? So we can take the idea of separate and integrate, and we can actually add a few extra letters to it. We can say separate, integrate, solve for c, isolate, and then select si, sis, okay? So some people will refer to that, okay, sis. So you know what separate and integrate is. You solve for c then is the third thing. Some people will mix up and they'll try and get y alone before they solve for c, but you want to solve for c first. And so you use the given initial condition, the initial value. Isolate means to solve for y after you've found your value for c. And then to select means choose between the plus or minus if applicable, okay, if your problem has a plus or minus. So when would you have a plus or minus? If you took a square root, you would have a plus or minus. If you took off an absolute value, you have a plus or minus. Okay, so in those situations, square roots are absolute values. So maybe we can, well, not just square roots, even roots. And then absolute values would be the other time you would do that. So let's practice finding a particular solution. That means you're going to find the value of plus c for the following differential equation, described in terms of both x and y, given the initial condition of the point 1, 2. All right, so let's start with separate. So our dy dx, and we're going to factor out the common value of x. So that leaves me with y minus 3. So that's the separate part. You just get a point just for doing that, okay? So we're going to put y minus 3, and then we'll have x dx. So you've automatically earned a point. If you don't start with separation, these problems are almost always worth 5 points. The 5 points are assigned this way for SISIS. It's almost always a 5-point part of the question on the FRQ, but if you don't start with separation, you get 0 for 5. You can't get any recovery points. So make sure you start with separation. And then we're going to move to the integration part. So the integration is going to be the natural log of the, here's where your absolute value comes in, y minus 3. And then on the other side, 1/2 x squared plus the constant c. So now you just have earned 2 points. Now we're going to substitute and we're going to find our value for c. So we'll have the natural log of the absolute value of 2 minus 3. So you can see why the absolute values are important, because we're going to end up with a negative value there. And then 1/2 times 1 squared. So we end up with the natural log of the absolute value of -1 equals 1/2 plus c. Now the absolute value of -1 is +1. So we can say, all right, I'm going to take off the absolute value and make that a +1, and the natural log of +1 is 0. So that means c is -1/2. So then we're ready to get y by itself. So we're back to now, so we've done the separate, the integrate, solve for c, and now we're going to isolate y. So we've got 1/2 x squared minus 1/2. I'm going to apply the e to both sides. So that's going to give me e to the quantity 1/2 x squared minus 1/2. Okay, it's not separate. It's not an e applied to each of them. It's an e applied to the quantity. Then I take away the absolute values, and that's where the plus or minus kicks in on the e side. And then I'm going to add 3. So I end up with 3 plus or minus e to the 1/2 x squared minus 1/2. And now I need to select whether I'm going to use the positive or the negative version of this equation. So I need to look back at my initial condition. If I plug in 1, I need to make sure I get 2. So if I plug in the number 1 right here, I'm going to get y equals 3 plus or minus e to the, and I'm going to get e to the 0, which is 1. So this will be 3 plus or minus 1. So how will I guarantee I get 2 as an answer? Well, it has to be 3 minus 1. So I'm going to select that, and so my final answer would be 3 minus e to the quantity 1/2 x squared minus 1/2. All right, and that's the 5 points that you would have for solving a separate and integrate question. All right, some AP exam tips. These separate and integrate questions almost always are going to be non-calculator. So that means it's toward the end of the test, like problem 5 or problem 6. So your first 2 FRQs are going to be with a calculator, and then the next 4 are going to be without. And these separate and integrate ones almost always come up on the non-calculator section. They are usually connected to one of 2 things. So they're either connected to either a word problem, so that's in context, or it's connected to a slope field. So either one of those. So the problem would maybe start out with a word problem and then build into separate and integrate to solve that word problem. Or it would start with a slope field and have you work on the slope field a minute and then have you separate and integrate to solve the solution to that slope field. So usually connected to those 2 things. And then they are worth 5 points. And that's for that SIS strategy. Okay, so you're good to go on separate and integrate differential equations. You'll have some slope field questions, you'll have some word problem questions to help you practice this particular unit, okay? And then remember, we'll come back on Friday and we'll do another 15-minute timed FRQ in class together. All right, so see you Friday.